We're talking about application of graphing linear equations, which is topic 6 to Desmos. And one of the things that we can do to draw a graph is to show that points lie on a straight line is just to enter values in a table form. So, for example, here I have a range of x values. In the y column, I type in x plus 1 because the equation that I'm looking at is x plus 1. So I put that over here. Now, I add another column for y, and it actually calculates it for me here. That's because if I just put in x plus 1, the values will appear over here in the graph, the ordered pairs, but I won't actually see the y values. So now I know the ordered pair minus 1, 0, 0, 1, 1, 2, etc. So that's just an alternate way. Of course, we can just enter the equation into a box as an equation and we will get the straight line. So that's the simplest way, but it's always interesting to see if there's a way that you can do things another way. So here we've entered a second column for y so that we can calculate a numerical value for y. So let's see some examples here. Page 20, example 1. Use the intercepts to graph the linear equation in 2x plus 3y equals 6. So over here, first of all, what I've done is I've just entered the equation, and I can get the intercepts this way, or I can check. So I'm just looking at the equation of the line. Of course, this really doesn't answer the problem here, but it gives me some sense of what the equation is like. So now, if we enter the intercepts, of course, how do we enter the intercepts? We set x equal to 0. When x is equal to 0, 3y equals 6, so y equals 2. And then we set y equal to 0, and when y is 0, x equals 3. So if we want to, we can enter the point 0, 2, and 3, 0, and show that they lie on the same straight line. So here, you see, we've taken the points, the ordered pair 3, 0, and it lies on the line 2x plus 3y equals 6. So we know these must be the right intercept values, otherwise they wouldn't lie on the line of the equation. Now we can also do this, really, here's the way, the proper way to do it is to put the 0, 2, in other words, the x-intercept right over here, excuse me, the y-intercept right over here, and then the x-intercept, which is over here, and then click on this line to join the points, and you can see that this line here is the same as this line over here. So really the way to do this, proper way to do this, is to first of all enter these values, which you can do by calculation. As I said, set the x equal to 0, and then y is 2, set the y equal to 0, and then the x is 3. Put these in, and you can connect the points. Then you can put this line in and show that they superimpose. So it's just an application of Desmos that's kind of interesting. Now, use the intercepts to graph the following equation. We've done this problem before. We showed that the intercepts were minus 2 over 3, 0, and 0, minus 2. And we put them in, and we connect the points right here by clicking over here. And then what we do is put the, we can just put the equation in right over here. So here's the equation alone in box 1. And we can see that this intercept here which is minus 2/3, is minus decimal 667. So this one here is this one here. And then this one here is that one there. So here we've done it with, at this point, we've done it with just showing the points and connecting the line. And here we've done it with entering the actual equation. This is the beauty of Desmos. You just need to enter the equation. And if you use projection mode, you can click on the points and you can show the intercept. So here's the x-intercept, here's the y-intercept. Don't forget that minus 667 is equivalent to minus 2/3. This is the decimal form, and this is the fractional form. Okay, 21D. Complete the following ordered pairs for the following equation and graphing. So here, when x is 1 and we put x equal to 1 over here, y becomes equal to 2. We can solve this. Put 1 here and solve for y, and y becomes 2. Similarly, if we put 3 in for y, then 3 minus 3 is 0 and x equals 0. So we have our two ordered pairs. 1, 2, and 0, 3. Here they are. Here is x equal to 1, y equal to 2. That's this one. This one here is 0, 3. Okay, now what we do is we put this equation in, but we deactivate it. So we just click over here and deactivate it so it doesn't show. And then we activate it, and we see that the line, the extension of the line, falls on these values, the ordered pairs. So this is a check that we've done the problem correctly. Okay, problem 21, number 2K. When we use intercepts, so again, when x is 0, y is minus 1. You put x equal to 0 here. A quarter of minus 4 is minus 1. We put y equal to 0, and x comes out to be 4. So again, we put this in a table form value right over here, and all we get is this here. So we get this. We've got the point 0, comma, minus 1 is this point right over here. And 4, 0 is this one. This is the y-intercept, and this is the x-intercept. Now, if we put the equation this in and activate it, we see that the extension of the line obtained from this falls on these points. So this gives us some applications and shows us the use of Desmos in graphing linear equations.